Hello friends, welcome to BMS Learning. In this video, I'm going to talk about rate zonal centrifugation. The key point in this centrifugation method is that the medium through which centrifugation will take place is prepared in different concentrations. As you can see, the concentrations are in decreasing order. Or simply say, we make the most concentrated solution and then dilute it to get various required concentrations. So in this technique, the centrifuge tube is first filled with different concentrations of matrix forming substance. As you can see, the density of the matrix in the tube is adjusted. So that means the matrix forming substance is chosen in such a way that it establishes layers with different densities and viscosities, thus forming a density gradient, such that topmost layer is having lowest density and the layer at the bottom is the most dense. While in the middle you have all different densities of the medium which are gradually getting dense as you come down. So we can say this layer is having intermediate density which is more than the top and lower than the bottom. It should be noted, when adding the higher concentration of medium, the tip of the pipette should be placed at the bottom of the gradient column. You must also avoid disturbing the interface between the layers. The prepared gradient should be used as soon as possible to avoid premature diffusion of the gradient layers. Now let's move to the centrifugation step. So we have prepared the density gradient column. What we are going to do is that a suspension of the particles is layered over the top of the solution in the column. And then we put this density gradient column in a centrifuge machine. So what would happen? The centrifuge is going to spin the column, and the centrifugal force exerted by the spinning of the centrifugal tube will cause the separation of the particles. In a sense, the technique is very simple. On centrifugation, particles move away from the starting zone with velocities determined by their size, shape, and by the centrifugal force to which they are subjected. So we can say the method separates the particles on the basis of their size as compared to isopycnic centrifugation, which uses buoyant density for particle separation. Let's suppose the suspension had different sized particles. The larger particles will be able to travel to the bottom layer because they are more massive. It's because the greater mass allows the particles to travel through layers with a greater viscosity, while the smaller particles will remain at the top, as they lack the mass to travel through the more viscous layers. And talking about the average particles, they would migrate up to the middle portion. So, after centrifugation, particles will be found in a series of zones or bands, spaced according to the relative velocities of the particles.